Hello, today we're going to learn what computer vision is. Today, we will learn what computer vision is and explain various computer vision technologies. And in today's lecture, we're not going to learn AI programming. Before starting the lecture, I would like to apologize to the visually impaired. This lecture utilizes a lot of visual contents, and we expect that some of you may have difficulty understanding our explanations in some parts. In the future, we will try to develop lectures for people with visual impairments. Now, let's talk about what computer vision is. Computer vision is the technology of extracting information or deriving meaning from an image or a video. Simply put, computer vision is a technology that mimics the functions of the human eye. Many people use the terms computer vision and image processing interchangeably. However, strictly speaking, image processing is different from computer vision. Image processing is the technology of manipulating images. For example, changing the color of an image is a type of image processing technology. However, this color changing technology is not a computer vision technology. Of course, there are cases where image processing technology is used in the implementation of computer vision technology. In general, the human eye plays a very important role in understanding the world. Therefore, computer vision technology that mimics the function of the human eye is also useful in many industries. In modern society, computer vision AI technology is widely used from autonomous driving to manufacturing. There are various fields of research in computer vision. Today, we'll introduce some popular techniques in the field of computer vision. Although some of the people watching the lectures may not be interested in computer vision technology, if you have a basic knowledge of computer vision, it may be helpful for future studies or work in AI domain. Let's start with an introduction to computer vision technologies. First of all, the image classifier we learned in the previous lectures is a type of computer vision technology. Image classification technology is used in various industries, but it also has some problems. For example, in many of the photos we take in our daily life, there is not only one kind of object. In the case of the multi-class single label classifier built in the last class, it is generally used for recognizing one type of object in a certain photo. However, as I said before, there are often many different types of objects in photos handled in industry or daily life. The technology that is being developed to solve the limitations of image classification AI is the object detection technology. Object detection technology, also called object recognition, is a technology that finds several types of objects in an image. To explain this technique a little more simply, you can think of it as a technique to find the type of object you're looking for in an image and draw a box where that object is located. Image segmentation is a technique also called semantic segmentation. Image segmentation technology extracts exactly what kind of object exists in which area of the image. If you've ever used Photoshop, you've probably used the lasso tool to select specific areas of an image. As such, the image segmentation technology finds out which object exists in which pixels rather than simply drawing a box where the object exists. Object counting is a technique for counting how many objects exist in an image. Of course, this AI can also be implemented by using object detection or image segmentation to find objects and count the number of found objects. However, when implementing AI that simply counts the number of objects, an object detection model is usually not used, but a separate model or algorithm is often used. Real-time object detection technology is a technology that finds objects in videos. The human eye generally recognizes image change of more than 30 times per second as a video. Therefore, a real-time object detection technology generally refers to AI technology that can find specific objects in more than 30 images per second. Some models used for object detection can process more than 30 images per second, so they are also used for real-time object detection. Object tracking is a technology that tracks objects in videos. You might think of this technology as the same technology as real-time object detection, but they are different. When we think of video as a bundle of consecutive images, object tracking requires a technology to determine whether the object that appears continuously in the images is the same object. An object detection technology simply draws a box at the location of the object without considering the relationship between the images. Thus, the two techniques use different models or are only partially similar. Of course, there are cases where object detection technology is used to implement object tracking technology. OCR stands for Optical Character Recognition and is a technology utilized to extract text from images. This technology has a long history and was developed with the goal of making text comprehensible to people with visual impairments. Recently, various cloud services offer OCR technology. The technology to translate foreign languages seen by the camera in mobile applications such as Google Translate is also implemented based on OCR. This technology has been very advanced recently, so you usually don't need to implement your own AI model. We recommend that you purchase commercial software and utilize the technology. If you need free open source software, you can find libraries on GitHub and use them. Face recognition is a type of object detection technology. The technique of finding a face in a video is especially used a lot, so I will explain it separately. Since this technology is often used, it is more developed field than finding other kinds of things. Face recognition AI can be implemented using object recognition models, but it is common to use AI models specialized for face recognition. Face alignment technology is a technology that identifies the geometric structure of the face in the image. The technique of extracting the areas of eyes, nose, and mouth, which are mainly called landmarks of the face, is called face alignment. Facial expression recognition technology classifies expressions from facial images. Naturally, to implement this technology, we must first find the human face in the image. Facial verification is a technique that checks whether the person in each of two given images is the same person. Facial identification is a technology that, when a face photo is given, compares the face photo with faces in the existing face database and identifies which face the given face photo is from among the faces in the database. Unlike facial comparison, it requires a facial database, and many people are concerned about the development of this technology. Now, let's compare the implementation difficulty of computer vision technology. Relatively much progress has been made in image classification, object detection, and image segmentation, and various open sources exist. Of course, these technologies are still not perfect, but compared to other technologies, it is easier to find information or libraries necessary for implementation. Also, face detection and OCR are highly developed fields. Techniques that are a little more difficult to implement than these techniques are as follows. In the case of real-time object detection, it is necessary to increase the inference speed per second, which increases the technical difficulty of applying it to the industrial sites. In addition, technology to recognize small objects in images and technology to recognize objects in large images are also difficult to implement. And there are still areas where AI technology cannot replace humans. Understanding complex events or human behavior in a video is much more difficult to implement than the techniques described in the previous slides. For example, it is harder than you think to classify all kinds of human actions in a shopping mall with an AI. This is because it is difficult to not only simply find the person and determine what kind of behavior they're doing with the software, but also classify all the actions of a person. In the case of humans, looking at something, they can process a lot of information by themselves and acquire new knowledge. On the other hand, modern AI technology can only extract limited information in a limited way, and it is difficult to learn by itself based on the given information. Many researchers and large companies are working on the technology to understand complex events in video, but the technology is not yet mature. In general, the more difficult a technology is to implement, the more expensive it is to implement, and the lower the accuracy or performance of the technology. Recently, deep learning technology has been used to implement various computer vision technologies. In particular, supervised learning techniques are widely used in computer vision AI models. For example, a recently used object detection model is a neural network model called FASTER-RCNN. And MASK-RCNN, which is widely used for image segmentation, is also a neural network model. Therefore, when building a general computer vision AI model, image data is first collected, training data is prepared based on it, and then the model is trained. If it is determined that the training data of the model is insufficient, the model is trained again by collecting more training data. Or we can change the algorithm to improve the performance of the model. Then, the trained model is used to perform a specific task. Facebook is investing heavily in computer vision technology research. In the case of ResNet, which was briefly explained in the previous lecture, it was developed by Kai-Ming He working at Facebook AI Research. And the FASTER-RCNN I just mentioned was also developed by Ross Gershik of Facebook AI Research with Kai-Ming He. In addition, MASK-RCNN, which is widely used to implement image segmentation AI, was also devised by Kai-Ming He and Ross Gershik. Facebook is also developing a deep learning framework called PyTorch. If you want to continue studying computer vision technology in the future, we recommend that you study PyTorch. And it's good to pay attention to Facebook AI Research, which has researchers who have had a lot of influence on modern computer vision technology. Facebook AI Research is releasing various open source libraries, and you can check out these libraries by visiting the GitHub page of Facebook AI Research. We also plan to offer courses related to computer vision technology in the future. It is expected that some of you will want to study data science after taking this course. However, data science requires more knowledge of mathematics or statistics than knowledge of deep learning. Therefore, if you want to study data science, we recommend that you study math and statistics first, and then study data science. It is expected that some of you would like to study natural language processing. Some researchers say that natural language processing technology is similar regardless of the language, but in most cases, the grammar or processing method is different for each language. Because learning English language processing skills does not give you the ability to process your own language, it is difficult for us to provide educational materials for non-English speakers. Some of you may want to study computer audition technology. Computer audition techniques are techniques that mimic the functioning of the human ear. This technology, like computer vision technology, is also quite advanced. However, this technology is being developed mainly by large enterprises, and large enterprises have already applied computer audition technology to their products and are selling them in cloud services. You can find open source software, but the performance is inferior to commercial software, and it is not easy to implement this technology yourself. Unless your goal is to become a researcher studying deep learning technology, you do not need to fully understand AI technology. Instead, by learning how to use open source libraries, you can quickly build the model you want. We will also be releasing a course that will teach you how to build an object detection AI soon, so please stay tuned. This is the end of today's lecture. In the next lecture, we will learn the basic syntax of PyTorch.